Hello students, welcome to EPG Pathshala. I am Dr. Ayushi Paliwal from University of Delhi. So students, today we are going to discuss about the module Metals and Civilization and the importance of metals in engineering applications from the paper Functional Materials. The purpose of this module is to make the students familiar with, to show the importance in the development of modern society. Second, the gradual development in metal technology. And third is the contribution by India to metal technology. So students, let us start with the basic introduction about the module. The present day civilization about the materials depends heavily on the knowledge and utilization of different materials and alloys in various applications ranging from heavy engineering fields to common households. Ancient humans, they gathered knowledge of metals that it is a shiny and hard object which can be hammered into useful shapes depending on the specific purpose. For example, blacksmiths used to give shapes suitable for hunting or killing enemies. On the other hand, craftsmen, they used to have cutting tools made out of metals for easy operation and cutting of woods or stones for making aesthetic items. Later it was realized that metals, they have load carrying ability which can be made use of in structural applications like making buildings, structures, transportation, bridges, etc. Gradually, other aspects, starting from heavy engineering to functional usefulness, like catalysis, magnetic, etc., they have been realized in much later time. Hence, the importance of metals and alloys were felt in ancient time and it became inseparable part of human civilization. Eventually, modern civilization is completely based on the use of not only metals and alloys, rather the use of all four categories of materials, that is metals, ceramics, polymers and composites. First, man had the excitement of discovering fire, which was finally used for melting the metals in earthenware container, the modern name of which is crucible. Another discovery happened when the ancient man made the first casting by pouring the molten metals into a cavity and by placing the halves of a hollowed out clay or stone mold. The metal filled the cavity and took the shape of the cavity after solidification. There are huge numbers of artifacts like bronze swords, arrowheads, beads, sculptures, etc., recovered from different excavating sites all over the world. There were rich tradition and culture of metals working in Indus civilization like Mohenjo-daro and Harappan culture. Later on, the tradition of excellent metal working continued, and there are several examples which reflect the extraordinary craftsmanship of Indians. To mention a few, Delhi iron pillar, they originates from Gupta dynasty in 3rd century AD. Wood steel is another signature metallurgical wonder. Starting from Bronze Age to Iron Age in ancient times and down to modern advanced society, metals and alloys, they have always been the base manufacturing machinery, buildings, bridges, various structures, and numerable households.
Metals to alloys. Gradually, the art of blending metals was developed, and it was realized that an alloy, which is formed by the combination of two or more metals, was much stronger, harder, and tougher than the constituent metals. Probably the first alloy developed was bronze, which was nothing but composed of copper and tin. The ancient civilization could design different variants of bronze with varying hardness and workability by modifying the composition. It was realized that more tin made the object harder and vice versa. Iron was also found out as native metal state as meteoric iron, which North American Indians exploited for making weapons. Hence, iron and bronze, they were utilized in making weapons, cutting tools, and farming implements. Gradually, other applications were also realized, like copper for vessels and ornaments, tin, gold, and silver for ornaments, silver, brass, and bronze for coins, etc. Two metals in particular were considered to be the precious metals, gold and silver, because of the shining nature and more particularly their tarnish resistance property. These two metals were used in making jewelry, and possession of these two metals were marked as the index of richness. On the other hand, iron, copper, lead, tin, etc., they were considered to be the base metals. Iron, as it was mentioned above, that due to the inertness of gold and silver against environmental mitigation or corrosion and shining beautiful luster, they were considered to be the precious and wealth measurement index. Some of the early mentions of gold, there were some artifacts are found in 5th millennium BC in the cemeteries in Bulgaria in Europe. Elegant gold vessels, they were also discovered in from Mesopotamia ca 2500 BC. Even ancient Egypt is a source of spectacular gold castings ca 1300 BC. In Indian subcontinent, particularly Indus Valley sites such as Mohenjo-daro ca 3000 BC, gold and silver ornaments have been recovered. History of metals in India. While talking about the metal technology in ancient era, contribution of metal workers in Indian subcontinent is highly relevant and of extreme importance. It also allows us to appreciate the achievements of ancient Indian metallurgists. The rich heritage of Indian metallurgy, medicine, and mathematics and astronomy is indeed a matter of pride for India. India is considered to be the place where evidence of early zinc production has been spotted. Zinc is very difficult to smelt since it is volatile at the temperature where the zinc ore is smelted, that is around 1000 degrees Celsius. Hence, at the temperature of ore smelting, formed zinc vapor would get reoxidized and lost. In order to tackle this situation, downward distillation of zinc vapor would be required. Interestingly, before any other reports on the production of zinc anywhere in the world, extensive and semi-industrial production of metallic zinc was established at the Zawar in Rajasthan, India. An interesting method was designed where downward distillation of the zinc formed after smelting zinc ore using specially designed retorts with condensers and furnaces so that the smelted zinc vapor could cool down and form molten pool of zinc metal which could later be solidified. However, in 1740, commercial zinc smelting operations were established in Britain, and interestingly, it had surprising resemblance to the Zawar process.
Iron and steels in India. Iron was earlier made via solid state reaction or reduction as its melting point is 1539 degrees Celsius. In India, iron was used in late 2nd BC millennium. Later forging became popular and Delhi iron pillar is a classical example. India had the reputation of making high quality iron products. One of the most well-known product is Wood's steel. So 12th century Idrisi says the Hindus excel in the manufacture of iron. It is impossible to find anything to surpass the edge from Indian steel. Wood steel has actually played an important role in the development of metallurgy. Forged cannons made of bloom steels reflect the workmanship of Indian blacksmiths.
Other metals. Mercury is another metal of importance, especially for its alchemical importance in the ancient times. It is a volatile metal which can be easily produced by heating cinnabar followed by downward distillation. At room temperature, it is liquid too. Arthashastra of Kautilya, dating from the late 1st millennium BC onwards, mentions some of the early use of distillation of mercury. Mercury constituted lots of alchemical transmutation experiments in the Middle Ages in Europe as well as in Indian and alchemical texts were the precursors to the development of chemistry. There were also reports on the extensive use of copper, lead, tin, bronze, and brass in ancient Indian civilization too. Aesthetically designed dancing girl statue made of bronze from casting from Mohenjo-daro from the Indus Valley attracts special attention. Mirrors made of bronze. They were also used in ancient India. Doctor Sarada Srinivasan showed that the tradition of making metallic mirrors in South India from high tin bronze is still continuing. So now students, let us discuss the present day scenario. Currently, the modern civilization is extremely dependent on the metals and other materials like ceramics, polymers, and composites. Gradual change from Stone Age to Bronze and Iron Ages, and finally stepping into the modern society where demands of metals and alloys in almost all the applications is many folds. Gradual and systematic knowledge over the microstructure, properties, compositions, and processing acquirement over the years, starting from prehistoric time to the modern time, have helped human civilization to shape and develop, and finally stepping towards the massive advancement. Therefore, the journey through the primitive but classic ancient metal workers to the current state of art, well developed technological and progressive industrialization has been wonderful, and it will keep improving in years to come and enhance the lifestyle of modern man.
So, students, let us discuss some of the advantages of metals and alloys. First, the load carrying properties with strain hardening behavior, which allows to resist stress concentration and subsequent sudden failure. Second, the ability to be cast or worked or both to get to any shape as required. Third, the ease of processing. Fourth, the stability against environmental factors like corrosion, oxidation, wear, and erosion, with suitable choice of metals and alloying. And obviously, they are cost effective. Other functional properties like excellent thermal and electrical conductivity, magnetic properties, etc. They have a well versed knowledge over the years based on the processing and properties of metals and alloys.
Need based development. So, for the development, there is always a need. So, need for doing work easily and effectively actually develops varied metals. So, material tetrahedron, which is shown in this figure, is always followed while developing any material, and we always want to have a better performance. Many heavy engineering applications like transportation, that is in railways, cars, airplanes, etc., machineries, buildings, bridges, etc., cannot be thought of without the use of metals. So, students, now we will discussing that why the metals are important in engineering applications. Different materials used for manufacturing cutting tools. So students, this table lists the different materials which are used in cutting tool manufacturing, and as you can see that every material over here has got its unique advantage. So it is clear from the figure that the carbon tool steels, they have various advantages. That is, they are unstable, cheap, and their sharp cutting edge can be prepared, extremely sensitive to heat, and their hardness is HRC65. Next is high speed steel. Their hardness is little bit higher, 67, and they are moderate at high temperature and hardness retaining ability. They're extensively used on drill bits and taps. Next is HSS cobalt, and which that is their major advantage is that they're excellent heat resistant in case of high cobalt versions of high speed steel. Next is cast cobalt alloys, which are stable but they are expensive, however little fragile. Next is cemented carbide, which are very stable and they are highly resistant to abrasion. Next is ceramics. Ceramics are stable, they are moderately inexpensive, and they are usually desired in high speed applications but somewhat fragility. They are almost used exclusively on turning tool bits. Next is cermets. They are also moderately expensive and have a high abrasion resistance, and their hardness is HRC 93. The second last material is cubic boron nitride, which is having highest hardness substance, and they're also fragile to some extent, and they have extremely high abrasion resistance, which is used for hard machining. The last is the diamond. The diamond is stable, highly expensive, extremely fragile, and the hardest substance. They have excellent resistance to abrasion, and they are used where abrasive materials would wear anything else. Philosophy for the development of modern alloys. Likewise, though the modern materials based on oxides or carbides or borides, polymers, as well as composites, they have exciting usages. The bulk of engineering applications, metals and alloys are inevitable. Mainly heavy engineering applications like transportation, machineries, buildings, bridges, etc. They cannot be thought of without the use of metals. Of course, with time, there have been enormous property enhancements in conventional materials like steel, aluminium based, magnesium based, titanium based, nickel based, etc. Hence, opportunities of the usage of metals, they are also increasing. About the steel sector, there are several new steels that have been developed in order to meet the demands of need-based society. Advanced interstitial free steels with ppm level of carbon and nitrogen makes it suitable for use in the car body manufacturing. Managing steels are high alloyed steels with extremely high strength and toughness used specially in aerospace applications, thinner rocket and missile skins. These steels have good heat resistance till 400 degrees Celsius too. In this category of steels, two operations are combined: quenching to form martensite, followed by tempering or aging, where different intermetallic compounds are formed. These intermetallics offer ultra high strength at low carbon level. Interestingly, this category of steels falls under very low carbon, high alloyed, ultra high strength steels. It generally contains 15 to 25% nickel along with cobalt, titanium, molybdenum to form different intermetallics. So in principle, alloying element is 15 to 25 weight% nickel. Secondary alloying elements, which includes cobalt, molybdenum, and titanium, are added to produce intermetallic precipitates. Chromium is also added to provide corrosion resistance. There are also variants of iron, manganese, maraging steels, where TRIP, that is transformation induced plasticity, can be utilized due to high manganese presence. In railways, steel is the backbone as well as the body. Standard carbon manganese steels, they are used for rails, that is 0.7 to 0.8% carbon, wheels 0.5 to 0.6% carbon, and axles 0.3 to 0.4%, with small addition of other elements or occasionally very small amount of costly alloying elements like molybdenum, chromium, and vanadium. However, to go at par with the increased demand to carry more loads, new materials are being developed for rails, axles, and wheels based on microalloying and benetic microstructures. These new steels, they are supposed to provide better structural integrity, higher load carrying ability, better protection against environmental corrosive actions, etc. Since strengthening of railway steel in the perilithic morphology by changing the phase fraction, fineness in interlamellar spacing, and microalloying have reached to its limit. New steels with novel benetic morphology are being considered to be the next generation railway application materials. Moreover, life of the new benetic steels will be decided by other important factors like their resistance against atmospheric corrosion.
Now let us discuss about the aluminium alloys. Aluminium alloys, they are extremely important whenever the high strength is warranted in association with less weight because of their excellent specific strength, high strength to width ratio, excellent corrosion resistance, and ease of formability. Typically, copper, silicon, manganese, tin, and zinc, they are used as alloying elements to base aluminium either to form wrought or cast products. So the aluminium alloys, they find extreme importance in both the common use as well as the specialized uses like car engines, car body, aircraft body, etc. So there are different variants of aluminium alloys depending on the nature of preparation, cast or wrought, kind of alloying elements, copper, zinc, manganese, silicon, etc. or type of heat treatments T1, T2, T3, T4, etc. Out of all the usages, wrought products, they find maximum usage 80 to 85%. For example, rolled plate, foils, and extrusions. Aluminium alloys, they have low melting temperature, enabling low cost aluminium cost. They have a very low cost aluminium castings. However, the tensile properties of the cast aluminium products, they are poor as compared to wrought invariants. The aluminium silicon alloys, they are the most important cast aluminium alloys which have excellent casting properties. Aluminium alloys, they have excellent corrosion resistance too. Nowadays, active research is still going on to enhance the properties of newly developed aluminium alloys. Recent review by Miller has convincingly expressed the recent development in aluminium alloys.
Titanium alloys. Titanium alloys, they are considered as one of the exotic metallic alloys, and it is also called as non-ferrous steel because of very high tensile strength and toughness even at extremely high temperature. In addition, these alloys, they are lightweight and have excellent corrosion resistance. Though these alloys are costly due to high priced raw materials and well costly processing, these alloys are used in special uses in healthcare, for example, orthopedic and dental implants, military applications, aircraft, spacecraft, medical devices, highly stressed components, for example, connecting rods on expensive sports cars, sports equipment, and electronics industries.
Now let us discuss about other types of alloys. In addition, there are some special alloys used in extremely hostile applications which involves high temperature, oxidizing environment, nuclear applications, etc. Superalloys, they are such high performance alloys which possess excellent mechanical strength, resistance to thermal creep, deformation, good surface stability and resistance to corrosion or oxidation. Some of the examples are Hastelloy, Inconel, Vaspalloy, Rennie alloys, Haynes alloy, Incolloy, MP98T, TMS alloys, and CMS-X single crystal alloys. So the development of superalloy depends on both the chemical and the process innovations. For example, high temperature strength of superalloys stem from both the solid solution strengthening as well as the precipitation of matching phases like gamma prime. Many times the oxide strengthening alloys are also used. Elements like aluminium and chromium, they provide the corrosion and oxidation resistance. Superalloys, they find application in making turbine blades and engines used in both aerospace and marine.
So, students, we have explored and discussed that metals, they are extremely important in engineering applications. So now we will discuss the future availability of the metals. So metals and alloys, they are extremely important in engineering applications. However, increased need of the metals and its consumption poses a serious consequence in terms of future availability of the metals and alloys. One such example is in the production of steels. The availability of good quality iron ore and coal is a problem in near future since reserve of these high quality raw materials is gradually diminishing. Therefore, there is an urgent need to improve on the refining process so as to make use of low grade ore as well coal for producing steel at compatible cost. Similar is the case in the case of other metals. In addition, recycling of metal objects as well as waste management, they are going extremely important factors in near future. Already technologists they are giving stress on the recycling of the metals for better cost effective use. Therefore, future of the metals and alloys lies on the development of advanced technology to deal with the poor grade raw material, judicial use of the metals with less wastage and need for recycling of used metals to meet the need of human civilization with minimal cost implication.
So, students, let us summarize what we have learned in this module. First, the contribution by India towards the development of metals and alloys is discussed. Second, iron and steel, they were the main metals developed by India. Third, the advantages of metals and alloys. Fourth, different materials along with their properties used for cutting tools, they are discussed. Fifth, the philosophy for the development of modern alloys. Lastly, the properties of various alloys like steel, aluminium, titanium, and other alloys, they are discussed. Thank you.